A visible spectrum of light lies between 723 nanometer to 397 nanometer. You know that light is made up of 7 colors, that is called as a Fibgor. Light ray is the term used to describe the radius of the concentric waveform. A group of parallel rays of light is called as a beam of light. Light scatters as goes. So when you throw a light, it starts scattering and it loses energy the further away from its source. What are the properties of light? You know that light is transmitted, the light is reflected, light is scattered, light is absorbed, and light is refracted. So when there is a reflection, the light is in the same medium. When the light is refracted, it transmits its light, or it travels from one medium to another medium. Light rays are parallel, converging, or diverging. The media of the eye are permeable to the visible rays between 600 nanometer and 390 nanometers. Cornea absorbs rays shorter than 295 nanometer, and lens, the crystalline lens, absorbs rays shorter than 350 nanometer. So rays between 600 nanometer and 350 nanometer reach the retina in phakic eyes, and 600 to 295 nanometer rays in aphakic eyes. What is the importance of this line? So when you operate a patient, in olden days we were operating without implantation of lens, because we were not having intraocular lens implant at that time. So after invention of intraocular lens, we started a intraocular lens surgery. So in olden days, when the lens was removed, so the patient was becoming aphakic, and all 600 to 295 nanometer rays, they were going inside the eye and they were toxic to the retina. So after the invention of intraocular lens, we have designed the intraocular lens called as a UV absorbing lens. If you see on the packet of an intraocular lens, it is written that UV absorbing lens. So the toxic rays, they are absorbed by this intraocular lens and they are not allowed to reach the retina. So this is the important to remember. So we should know something about what is a geometric optics. Behavior of light rays is determined by ray optics. Light follows a straight line path for travel. The ray optics uses the geometry of straight lines. Knowledge of geometric optics is essential to understand optics of the eye, errors of refraction and their correction. Reflection of light. A phenomenon of change in the path of light rays without any change in the medium is called as a reflection. There are incident rays, reflected rays, and there is a normal. The incident ray is light rays falling on a reflecting surface. Reflected rays is light rays reflected from the surface, and normal is a line drawn at right angles to the surface. In this picture you can see the incident ray. There is an angle of incidence, there is an angle of reflection, and the angle of incidence and angle of reflection, they are same. There is a reflecting surface. In this picture it is a mirror. When light meets any surface, a reflection of light occurs. These are the reflections from the surface. So if the surface of water is smooth, you get a crystal clear reflection, and if there is a wavy water surface, the reflection of the object is not a good quality. Also, according to the surface, you can have a reflection from convex and concave surfaces. So if you look into the outside of the spoon bowl, the reflection is different, and the inside spoon bowl, because it depends on the curvature of a surface, whether it is a flat or curve. The curve is outside or curve is inside. So we should see something about the mirrors. A smooth and well polished surface which reflects regularly most of the light falling on it is called as a mirror. We are having two types of mirror, that is a plane mirror and a spherical mirror. So in plane mirror, The image is same size of the object, it lies at the same distance behind the mirror as the object is in front, and it is laterally inverted, virtual in nature. So in this picture there are three figures. One is candlelight in front of the mirror. So you can see that it is as good as in front of the mirror, the reflection will be, or the image will be behind the mirror. Just it is laterally inverted. There is another variety, that is a spherical mirror. A spherical mirror is a part of a hollow sphere whose one side is silvered and the other side is polished. Again, there are two types, concave mirror and convex mirror. These are the curved surfaces of mirrors. In concave mirror, the image is in front of the curved surface, and in convex, it is opposite to the curved surface. A concave mirror is that mirror whose reflecting surface is toward the center of the glass sphere of which the mirror is a part. In concave mirror, the reflection of light rays takes place from the inner surface while the outer surface is polished. And in convex mirror, a convex mirror is that mirror whose reflecting surface is away from the center of the glass sphere of which the mirror is a part. In convex mirror, the reflection of light rays takes place from the outer surface while the inner surface is opaque. You should know something about the cardinal points of a concave mirror. Center of curvature, radius of curvature, pole of the mirror, principal axis of the mirror, they are depicted in this picture. That is, C is center of curvature, F is the, then there is radius of curvature, P is the pole of the mirror, and F is the focal length, and F is the big F is principal axis, principal focus, and small f is focal length. Cardinal data of a spherical mirror. The center of curvature and radius of curvature of a spherical mirror are the center and radius of the sphere of which the mirror forms a part. Normal to the spherical mirror at any point is the line joining that point to the center of curvature. This is called as a normal. Then pole of the mirror is the center of reflecting surface. Principal axis of the mirror is a straight line joining the pole and center of reflecting surface. Principal axis of the mirror is the straight line joining the pole and center of curvature of spherical mirror. It is extended on both sides. Principal focus is a point on the principal axis of the mirror at which ray incident on the mirror in a direction parallel to principal axis. The rays coming to the mirror which are parallel to the principal axis, they meet at the principal focus in concave mirrors or appear to diverge in convex mirror after reflection. Focal length of the mirror is the distance of principal focus from the pole of the spherical mirror. This is called as a focal length. How the images are formed by a concave mirror. The position, size and nature of image formed by a concave mirror is different as per the position of the objects in front of the mirror. The images formed by concave mirror, the position of the objects placed can be at infinity, beyond the center of curvature, at the center of curvature, between this F and C, object at this principal focus, and object is between pole of mirror and focus. So this is a homework for you. You have to write and draw the figures of images formed by concave mirror. Just I will show you. This is a homework for you. Images formed by concave mirror according to position of the objects. So when the object is at infinity, as you know that rays coming from far away, they are parallel to the axis, and after reflection they will come to a point focus at the principal focus, and here you will get a real inverted and very small image. Just like that, if the object is placed beyond the center of curvature C, then the image position will be between the principal focus F and the center of curvature C. This is a real diminished size and inverted. Just like the image is formed at the object object is at the center of curvature, you have to. Then if the object is between the principal focus and center of curvature, what is the position of? Then the object at principal focus, where the image will be. If the object is between the pole of mirror and principal focus, where the image will be in a concave mirror. Then we will come to another topic, that is the refraction of light. So we have studied what is the reflection of light. We have studied about the mirrors, plane mirror and spherical mirror. Now we will see something about this refraction of light. It is the phenomenon of change in the path of light when it goes from one medium to another. Basic cause of refraction is change in the velocity of light. In this picture, the picture depicted is that the boy and the girl, they are running or walking on the surface of sand. So the speed of walking or running in the sand is different when they will enter into the water. So when they change the surface or the sand to the water, the speed of running or the speed of walking is changed. Just like that, as light goes from one medium to another, the velocity changes. So the incident ray and refracted rays, they are on the opposite side of the normal. The incident ray is depicted as a small I and refracted as a small r in the refraction. The ratio of sine of angle of incidence to the angle of refraction is constant for the part of media. This constant is called as the refractive index of the medium 2, in which the refracted ray lies with respect to medium 1. So when the medium 1 is air or vacuum, then N is the refractive index of the medium 2. This is Snell's law of refraction. We know that the speed of light in the air or vacuum is 3 lakhs km per second. But the speed of light will change when it changes the medium. So when the light travels from air to glass, the speed changes, and as the speed changes, there is a bending of light occurs. This bending of light is called as a refraction when the light passes from one medium to another medium. So in this picture, we have seen a glass filled with water and there is a spoon in it. So when an observer looks to the spoon from outside, the rays coming from the water, that is a thick medium, and the rays will at this coming through the air, the empty glass. So they will enter into the eye, and the position of the spoon will look as a different, because the rays, when they are changing the medium from water to air, they will change their path. There will be bending of the rays. So the object will not be seen at the place where it is present. When light travels from one medium to medium of different intensity, bending of rays occurs. And this phenomena is occurring in our eyes because cornea, aqueous, vitreous and lens, they are more dense than the air, and when the light comes in contact with the cornea, the aqueous and the lens, there is a change in the pathway of light. Just there is a change in the speed of light, and so there is a change in the path. In this picture again I have depicted, this is a fish tank. In this, the image seen by eye is different from the actual position of fish, because the rays coming from the actual position of fish, they will have a bending effect, and the image seen by eye will be different. So we should know something about the critical angle. The critical angle is defined as the angle of incidence that provides an angle of refraction of 90 degree. What it means? So when there is a light traveling from one medium to another medium, if it is traveling from a thicker medium to the rarer medium, the light will have an angle at the surface, that is called as a critical angle. In the second picture, the critical angle is such that the traveling light rays, when it comes to another surface, when it is changing the medium, it becomes flat. And in the third picture, the light coming from a medium 2, that is a thicker medium, to the rarer medium, the critical angle is such that it makes an angle of refraction that is more than 90 degrees, and the light is reflected in the same medium. It is not going outside that medium. This is called as a total internal reflection of light. It depends on the critical angle. Now we will see what is a prism. You know that when a light travels from a transparent object, it will pass through and through. So when a light is traveling from two transparent glass plate, it will transmit the light. There is no obstruction to the passage of light. But if the two glass plates we put in a inclined angle, they will form a curved part. This is called as a prism, which is a refracting medium having two plane surfaces inclined at an angle. So there is this incident ray and the emergent ray. But as there is an inclination of the glass plate, the incident ray will be seen as coming from a different part as an emergent ray. So the angle of deviation will be there. The greater the angle of formed at the apex, greater is the prismatic effect. The prism produces displacement of the object seen through it towards apex. Power of a prism is measured in prism diameters. One prism diameter produces displacement of an object by 1 centimeter when kept at a distance of 1 meter. This is a refraction of light through prism. So when the white light comes in contact with the prism, it separates into its all 7 colors. That is a waveform. So according to the wavelength, the light separates. The prism is nothing but the prism, when it is attached as base to base, it forms a convex lens, and when it is apex to apex, it forms a concave lens. That we will discuss in next topic, next part. A lens is a transparent refracting medium bounded by two surfaces which forms a part of a sphere, that is a spherical lens, or a cylinder, that is a cylindrical lens. In this picture you can see a basketball. It has the curvature, so you can say vertical or all over the 360 meridian, the curvature is the same, so it is a spherical one. What is the cardinal data of lens? We have seen the cardinal data of concave mirror. Now we will see what is the cardinal data of a lens. So lens is having two surfaces. Mirror is having only one surface, reflecting surface, and the lens has refracting surface. It has a two curvature. One is the anterior, another is a posterior. But the other things, that is center of curvature, then radius of curvature, principal axis of the lens, optical center, that is nodal point of the thick lens, this is the O, and principal focus of a lens, focal length of lens, and power of lens. So this is another homework for you. You have to write down and draw the figure. What is the cardinal data of a lens? What are the cardinal data? The focal length of a lens is the distance between optical center and the principal focus. Just like mirror, there is a reflection. In lens there will be refraction of light. So there will be again this principal focus, focal length, then center of curvature, and the radius of curvature. Everything will be same as a mirror. The power of lens is the ability of a lens to converge or diverge a beam of light falling on lens. It is measured as a reciprocal of focal length in meters. P is equal to 1 by F. Then we are having types of lenses, that is spherical lens and cylindrical lenses. This has been covered in your clinical classes, how to identify spherical lens, how to identify a cylindrical lens. So spherical lenses, they are bounded by two spherical surfaces. Mainly they are having two types, convex and concave. So these are the two basic types of lens. So lens is bounded by two surfaces. So there is one anterior and posterior. When the light travels through the lens, through the convex lens, when it travels, it will come to a point, it will focus at a point. So this is the first focus. So that is called as a principal focus, and the distance from the optical center to that focus point is called as a focal length of that convex lens, or it can be applied as a for the concave lens. There will be diverging lens. So convex spherical lens, they are having biconvex, plano-convex or concavo-convex. A, B, C, these are the lenses, how they are looking. Then what is the refractive principle of a lens? The convex lens focuses light rays. So light from distant source will be focused at a particular point, and the distance from the center of this convex lens to the focused point of the light rays is called as a focal length of that convex lens, and that focal length is depicted as a dioptric value. If you divide 100 centimeter with the focal length, you get the dioptric value. So lenses are converging and diverging. Convex lenses, like mirror lenses, also take light rays from infinity, convert them to a specific point called the focal point. The difference is that lens does not have a center of curvature, but rather has a focal point on each side of the lens. That is called as a principal focus. The refractive principles of a lens. So the lenses can have a dioptric value, that is 1 diopter. It means the rays coming from far infinity will be focused at 1 meter when they are allowed to pass through the lens. 2 diopters means the lens will converge the lens at 0.5 or 50 centimeter. So the lens is having a 2 diopter value, and the 10 diopter value of the lens means the rays coming from far infinity, they will be focused at 10 centimeter when they are allowed to pass through the convex lens. So light from distant source, the closer the light source, the longer is the focal distance, and the rounder the lens, the shorter the focal distance. So this will be valuable for your understanding that when the light is coming from far away, it will focus near to the lens of the opposite side. If the light is coming from closer object, light is from the close object, the rays will be divergent. The rays will be divergent, and they have to have too much bending, and for that too much bending, the lens has to change its shape, and that changing the shape of the lens is called as accommodation. That is for focusing of near objects. Concave lens diverges light. So how to identify a convex sphere? So this has been covered in your clinical classes, but just to know, you have to hold the lens close to the eye. You have to move it vertical direction as well as in horizontal direction, and you have to see the image of object where it moves. If the image moves in opposite direction, in both vertical as well as horizontal direction, then you can call it as a convex lens. And if there is no distortion of image, it means it is a spherical one. If there is a magnification of an image, it is a convex sphere. The convex spherical lens is used for the correction of hypermetropia, compound hypermetropic astigmatism, magnifying glass, indirect ophthalmoscope, direct ophthalmoscope, microscope. So this is the third homework for you. You have to write down and draw the figures how the lens refracts refraction. So objects accordingly, what is the position of an image when the object is at different positions. So when the object is at infinity, for the purposes the rays coming from more than 6 meters, they are parallel. So the object from infinity will be focused after passing through a convex lens at a particular point. So what is the position? If the object is placed beyond 2f, means more than 2 of its focal length, where the position of the image of an object. If the object is at 2f, if the object is between focal length and 2f, then object at the principal focus and object distance less than the principal focus or less than the focal length. What are the images you will see? So this is just images formed by convex lens. This is a homework for you. So you have to write if the object is infinity, where the image will be and what type of image. So whether it will be real, small, inverted, what, just like a concave mirror, it will be applied to the convex lens. But as the mirror is having only one reflecting surface, the position of image is different, and the lens is having two surfaces. So the focusing of image will be different one. If the image is formed by convex lens and if the image is formed by concave lens. So this is a homework for you. Concave spherical lens, they are diverging lens, they are again biconcave, planoconcave and convexoconcave. How to identify? Again, it is the same principle. You have to hold close to the eye the lens given to you. Then again you have to move in vertical and horizontal direction. See where the image of the object is moving. If it is moving in the same direction in both this meridian, you can call it as it is a concave one. There is a spherical. If there is a minification, it is a concave one. If after rotation there is no distortion of image, it means it is a spherical one, it is not a cylindrical one. So the concave lenses are used for the correction of myopia, compound myopic astigmatism, used in Rabi lens, or in a direct ophthalmoscope you are using the concave spherical lens. Then image produced by concave lens. The concave lens always produces a virtual erect image of an object. As you know that the light coming from far away, after there is a refraction, it will seen as coming from the principal focus. It will focus in front of the concave lens. It will be seen as coming from this principal focus, first focus. What is cylindrical lens? A cylindrical lens acts only in one axis. Power is incorporated in one axis, the other axis having zero power. Convex cylinder has a segment of a cylinder of glass cut parallel to its axis. Lens cast in a convex cylindrical mold is called a concave cylindrical lens. These are the pictures. So if they are making a contact, you can very well come to know that from a cylinder, if you take a vertical cut from a cylinder, you get one surface that is a spherical, just like a convex, another is a flat surface. So the cylinder has a action in only one axis, that is a parallel to its cylindrical axis. Another is a concave cylindrical lens. How to identify the cylindrical lenses? Also it has been covered in your clinical classes. But if you are looking through a cylindrical lens, the after rotation of the lens, the image will be distorted, and whether it is a plus or minus, again the same principle. If the image moves in the opposite direction only in one meridian, that is a convex cylinder. If the image is moved in a same direction, that is a concave cylinder. There is distortion of image in cylindrical lenses. There is no distortion of image in spherical lenses. Then we will see a part that is called as a Sturm's conoid. This can be asked for your short note. We have seen the refraction of light will take place from surfaces. So in cornea you are having vertical as well as a horizontal meridian. So the light can travel through all the degrees of the, or you can say 360 meridian. But many times the corneal curvature is different in all the meridians, vertical meridian and horizontal meridian. So when the curvature is more, the bending of light is more. You know, vertical curvature is more, so the bending of rays which are coming through this vertical meridian, they will focus before the horizontal rays. So according to this, the Sturm's conoid is decided. So we will see what are the position. The configuration of rays refracted through a toric is called as a toric surface. The configuration of rays refracted through a toric surface is called the Sturm's conoid. So in the first picture you can see a basketball or a saucer ball. It is having a spherical shape, same curvature in all meridians. But in a rugby ball, it is a egg-shaped. You can have, there is a flat meridian and steep meridian. So if the light falls in such a surface, some rays will be focused earlier than other rays. So this is a toric surface or astigmatic surface. So this will be important from understanding point of view of astigmatism. The shape of bundle of light rays at different levels in Sturm's conoid is seen as. So the vertical meridian you call it as a VV and the horizontal meridian that is HH. So if the rays, if you make a diagram for this toric surface, there will be at a different sections you will get different varieties of focusing of images. At point A, the vertical rays are converging more than the horizontal rays. So we get a section as a horizontal oval or an oblate ellipse. At point B, that is the first focus, the vertical rays have come to a focus while horizontal rays are still converging. So they form a horizontal line. This will be important for understanding in astigmatic refractive error. So the rays which are falling in front of the retina, you call it as a myopia. The rays falling behind the retina, you call it as a hypermetropic. And in that, when the rays in a particular subject, they are having different refractive error, they will have a different positioning of images. So in astigmatic, there will be a focal line formation, and in spherical refractive error, there will be a focal point will be there. In astigmatic refractive error, there will be a vertical line or a horizontal line. So accordingly, what is the refractive error? In astigmatism, there can be 5 types of astigmatic refractive errors that will be dealt in your class in astigmatism. But just to know what is Sturm's conoid, you have to make this diagram again, and this should be again another homework for you. that is, draw a neat label diagram for this Sturm's conoid. So at different sections you will get different point of focus. So we have seen at A and B, then at point C the vertical rays are diverging and their divergence is less than convergence of horizontal rays, so a horizontal oval is formed. At point D, the divergence of vertical rays is exactly equal to convergence of horizontal rays. So here the section is a circle which is called as a circle of least diffusion. So at the circle of least diffusion you will have a good quality vision. At point E, the divergence of vertical rays is more than the convergence of horizontal rays, so the section here is a vertically oval. And at point F, this is called as the second focus. Horizontal rays have come to a focus, but vertical rays are divergent, so vertical line is formed. So the interval between the horizontal line, that is a B point, and the vertical line, that is the F, as a focal interval of Sturm. And beyond F and G, both horizontal and vertical rays are diverging, and so the section is vertically oval or prolate ellipse. According to the position of retina where it is, you are dividing the refractive error. So if the light falling in front of the retina, you call it as a myopic refractive error. If the rays are falling behind the retina, it is called as a hypermetropic error. And if the rays, they are falling one on the retina and one in front of the retina, you call it as an astigmatism, that is a myopic astigmatism. If one is in the retina, another behind, you call it the hypermetropic astigmatism. So it can be simple and it can be a compound, or it can be a mixed hypermetropic, mixed astigmatic error. So thank you. So this is a difficult topic of only physics. So you have to draw these figures and remember what is the image formed by all these concave mirror and the lenses to understand better the correction of refractive errors. Refractive error correction is nothing but a neutralization process. If the light is falling in front of the retina, you have to focus it on the retina. If the light is falling behind the retina, again you have to focus it on the retina, that is light sensitive layer of retina. So after this we will take another topic for optics of the eye, and then we will go for refractive errors corrections and what are the refractive errors. So that will be the next topic. Thank you.